Today I'm going to be doing an example in chapter 11. In particular, I'll be doing number 1. We'll start with number 1, which involves confidence intervals, which is an important technique for not just giving an estimate of the mean of some population, but give a range of values that we're pretty sure the right answer is in that range. So this example, nope, sorry about that. That was a different example. In this example, it's really a throwback to a previous chapter where we calculated the normal distribution. Now, this really requires some understanding of the theory, which I do provide in the videos that I've made for this class, in particular the videos that are found on the YouTube index, since they're YouTube videos. And I discussed the sampling distribution of the mean, the standard error of the mean, probabilities, etc. But now I'll just sort of go through the mechanics and a little bit of theory. So we know that 29% have high levels of cholesterol. Okay. I don't think that number is that relevant. Okay, so the average cholesterol is 206, but of course not everybody has 206. Some have 226, some have 230, some have 200, some have 190. There's a variation measured by the standard deviation of 30. And the data is roughly normally distributed, which is a requirement if our formula is going to give us accurate results. So, if the cholesterol's 47 patients are taken, what is the probability that the average of those 47 patients would be lower than 206? Well, if 206 is the average, that means half the data is above 206 and half the data is below 206. So technically you don't even need a calculation to do that. It's going to be 50%. But since we're going to be having to use the calculation for the subsequent parts of the problem, let me show you how you do it now. So the main thing to realize is that we're talking about averages. We're not talking about individuals. And averages are more stable than the individuals. In fact, that increased stability is measured by, when you're dealing with averages, you have a reduced standard deviation. And it's reduced according to the sample size. And for technical reasons, you divide by the square root of the sample size. So in this case, it's 47 is the sample size. And calculator, there was my phone. Excuse me, I needed to get my calculator. So we're going to take the 30 and divide it by the square root of 47. And that number is going to be, let's see, square root of 47 is equal to about 6.85. And we want to divide that into 30. 30 divided by 6.85. So let's take the inverse and multiply it. So in our case, the standard deviation is 4.37. Okay, so keep that number, 4.37. So now we go to StatCrunch. StatCrunch, which we're opening. We like to open. But when that doesn't happen, I go to statcrunch.com and just what we've done previously. And we're going to go to the calculators, normal calculator. And we want the standard, we want everything below 206. So in our case, the average 206. the standard deviation is not 30, it's going to be, what did I say, 4.37? Really 4.38 if you round it correctly. And we want everything below 206. Let's double check if that's actually the question. How many are below 206? And getting back to the calculator, which should be, where is it? Where are we? This, uh, oh, there it is. And you hit compute, and the answer is, as expected, is exactly 50%. So the answer to the question is 0.5. Check answer, and that has to be right. Okay, now how many are between 201 and 211? And again, the way you might have learned this in high school, perhaps, if you turn it into a z-score, you look up the z-score in the table, you subtract them. But with this amazing StatCrunch calculator, this is going to stay the same. The standard deviation of the average is still, we'll call the standard error of the mean, is still 4.38. But now we want answers between 201 and the upper level, which I already forgot, is 211. Compute, and the answer is 0.746. And we're on a roll. How many are lower than 196? Well, that got to be a small number. So it's way below 206. Get it exactly by going back to standard. And we're lower than 196. Now we say compute, and the answer is 0.011. Copy. No, it is more. What's the probability is greater than 218? All right, so it gives us an opportunity to go to StatCrunch, change this now to greater than, change this to 218, and the answer is small 0.003. And again, to really understand this, you should see the videos that I made on this topic.